Pencils down, colored pens up, and let's see how we're doing with understanding the different angle relationships that we are supposed to know so far. Number 1, angles 5 and 7, what relationship do they have? 1, 2, 3. We'll start with Stephanie, Sebastian, and then Stephen. Okay? You all think it's corresponding? It is corresponding. What about number 2, angles 3 and 6? We got Kamoy, Stephanie, and then Dainara.
Alternate interior angle. Alternate interior angle. Alternate interior.
This is alternate interior angles. What about number 3, angles 1 and 8? Angles 1 and 8. We got Nathaniel, Kadir, and then Alexandra.
Alternate exterior angles.
All 3 of you think it's alternate exterior angles. That's what it is. What about angles 9 and 14? What do we call that? We got Valerie, Nathaniel, and then Extol.
Alternate interior.
So we have a little bit of a disagreement, but these are vertical angles. And number 5, what about angle 12 and angle 8? What relationship do they have? Got back to Kamoy, back to Kayla, and then Stephanie. I call it same side interior or consecutive interior. It's the same thing. Very good. So I had a lot of students in my previous class with which I did this lesson. And I had a lot of students who missed number 4. Okay, just because I'm reviewing largely what we did last time doesn't mean that other things don't apply. In fact, you're going to start seeing today that everything is now bundled together. Everything is supposed to be coursing through your head. You're supposed to know all of these different ideas. Does anyone have any questions about these different relationships? Because everything you do today is based on this. Any questions? Okay? Today, we're going to explore what happens when we have parallel lines cut by a transversal. Our objectives today are to prove and use theorems about the angles formed when we have parallel lines and a transversal. So basically, and I'm going to rewind to the warm-up, we are actually talking about the exact same thing as you see here, except what happens when this line is parallel to this one. All of these different relationships take on a more significant meaning. What is their more significant meaning? We end up with postulates and theorems. So, we start out with the corresponding angles postulate. Don't write anything. We start out with the corresponding angles postulate. If 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So now we do not just have a pair of corresponding angles. Now we can say that those corresponding angles are congruent to each other. That's when we have parallel lines. And that is called the corresponding angles postulate. Any questions about that? Remember the difference between a postulate and a theorem. A postulate we just assume to be true without proving it. A theorem we are supposed to prove before we are allowed to use it. I'm going to allow us to use some theorems today that we don't prove, but technically we are supposed to prove them. Now let me pause here because I have a cheat sheet for you. That is why I said do not copy. So take a copy of the cheat sheet, and the staplers will go around again, and either keep it out of your notebook for today and then staple it in at the end of the lesson, or staple it in now, whatever you think is best. And we're going to go through the ideas. So, you see on your cheat sheet, corresponding angles postulate is there for you. The second is the first theorem today, the alternate interior angles theorem. So through the warm-up, we were able to confirm that most of you understood what alternate interior angles meant. But now when the lines are parallel, we can not only just identify them, but we can now say that if the two lines are parallel, alternate interior angles are congruent. Anyone have any questions about that? What is going on? Any questions about that? You can imagine what's going to happen next, for the most part. The alternate exterior angles theorem. We can not only identify alternate exterior angles, but if the two lines are parallel, we can say that they are congruent. Does anyone have any questions so far? The only theorem that's slightly different is the consecutive interior angles theorem, which you could also call the same side angles theorem, is that if you have a case of same side interior angles, they're not congruent, they are supplementary. So you should be able to identify them, but now you can say that they are supplementary. Does anyone have any questions about the postulate or the three theorems? So you need to know them, you need to know what they mean, and you need to know their names. So use the cheat sheet, use it today, use it tonight, but eventually it should start to stick. If it doesn't, form note cards and study them. Now we're going to use all of these to solve some problems. Plus, we're going to use things from the past. So here we go. I provided you with a ruler. You're going to need to sketch the picture. And an easy way to draw parallel lines with a ruler is to hold the ruler steady and draw a line on one side and then draw the line on the other side. And that will automatically make parallel lines. So we need an approximation of this picture. So we have two lines that are parallel. We can see that from this indication right here. And then we have a transversal cutting across them. And what we are asked to do is find the value of x and also find the measure of two of the angles. So I'm going to give you a moment to sketch the picture, and then we will actually attack the problem. We are going to pull a lot from this one example. So try to stick with me and try to grasp the point of doing everything we do. We're going to spend a decent amount of time finding the value of x, and you'll understand why in a moment. I would like you to not write anything for about a minute or two. I'll tell you when to start writing again. But you're going to be thinking a lot, and you're going to be thinking about reasons. So I would like to find the value of x. We have this picture. We have a bunch of theorems and postulates. What could we set up to find the value of x? And if you didn't realize, this measurement is this angle here, This measurement is this angle here. So what could we set up? All right, we got Stephen, then Kayla, and then Kadir. Give me something. An equation. Excellent. So let's start with an equal sign. Good. What's going to go on the left and what's going to go on the right, Stephen? Okay, so Stephen is proposing that we can do this. What reason could you give to support his conjecture that we could do that? Is there a reason? Go ahead, Stephen. The corresponding angles postulate says that these two angles are congruent. And since they're congruent, their measures are equal. So we can set up this equation. Don't write anything yet. What else could we set up? I believe we had Kayla and then Kadir. Kayla, you were going to say the same thing. Kadir, same thing. Is there another equation we could set up? Matthew.
4x plus 22 equals 7. 4x plus 22 plus 70 equals
4x plus 22 plus 70 equals 180. What reason could you give for that? Okay, you're on the right path. This angle and this angle are a what? A linear pair. Beautiful. And linear pairs, by the linear pair postulate, are what? Supplementary. So you can say that this angle plus this angle must equal 180. Now we have another equation that we could use. I still don't want you to write. What else? Giamara? 5x plus 70 equals 180. Boy, I don't see that at all. Could you talk me through the reasons for that? Okay. So you actually used, think of a proof. Think of what she just did. She just did substitution. The corresponding angles postulate says that these two are congruent. And you think of that word I always use, interchangeable. So since we already established from Matthews that this plus this equals 180, then we could replace it and put 5x plus 70 as 180. Brilliant. Anyone see another one? Okay? No others? Good, we got 3 different equations. How many values of x should we find if we solved all 3 of them? How many different values of x should we find? Good boy? Yeah, they should all come out to the same answer, right? Okay, if you are one of the people who proposed the equation, you have to solve your own. Otherwise, pick one of the equations and solve one of them. You got 30 seconds. Go. Didn't even need 30 seconds, did you? So what is the value of x? Valerie? Eric, do you agree?
Yes.
What did she say? X is 22 no matter which equation you solve. So based on all these different relationships, postulates, and theorems, we were able to figure out the value of x. And then from there, we can find the measure of ECF and the measure of DCE. So let's go ahead and address those last 2 bits of information. finding the measure of this and the measure of this. So the measure of angle ECF and the measure of angle DCE. ECF right here, how much would that be? Two people figured it out? 4 people? 5 people? Some people doing some intense mental math? Nathaniel?
70 degrees.
70 degrees? How could you be sure?
Because if you actually solve for DCE, which is equal to 110 degrees, and then put them both together, you can 180.
That was a wonderful explanation. If you actually filled in this expression with the value of x, that's 110 degrees, and these two are supplementary, so that would be 70. What's another reason that it's 70? That might be even a shorter path. Oh, we see some light bulbs going off now. Ziamara? Yeah, there's a 70 right here, and this angle is corresponding to this one, so by the corresponding angles postulate, that has to be 70 degrees. So, of course, he's right and she's right. It's 70 degrees. What about DCE? We already figured it out. Nathaniel, what was it?
110 degrees.
So Nathaniel solved both of them in one shot. Any comments, questions on what we did? Remember, all of these equations came from this one picture. They all found us the same thing, and we were able to pick out those angles. Any comments or questions? Okay, let's see what you can do on your own. I would like you to find me the measure of angle QRS. Find me the measure of angle QRS any way you can. You got 1. So what'd you get? Start with Alexandra, Eric, Stephanie, and then we'll go more if we need. What'd you get?
62
Okay.
62 degrees.
You all think it's 62 degrees because it's 62 degrees. Someone talk me through the logic. How'd you figure that out? Use actual geometric terms. Go ahead.
consecutive interior angles 0, and since it says there's supplementary angles,
Beautifully said. Beautifully said. So this angle here, excuse me, and this angle here are same side interior or consecutive interior, which are supplementary from the consecutive interior angles theorem. Which means they add up to 180, subtract this from 180, you get 62. Anyone do it differently? What'd you do, Steven?
Calculate the corresponding angles postulate. X is equal to 180 degrees. And since X and QRS means subtract.
Right, so for a different reason, you subtracted from 180. He saw that this angle and that one were corresponding angles, and from the postulate, they're congruent. And then from there, he saw this linear pair, and then subtracted from 180. Great job. So 2 different pathways to the same result. Any comments or questions on checkpoint number 1? So let's build from there, go a step further. Example 2, and yeah, again, you need the picture. So use your ruler. If you hold your ruler right here and draw one line on one side of the ruler and the other line on the other, you'll get perfect parallel lines. And then estimate the transversal, and then fill in the information. 2x minus 35 goes with this angle. That one's 75. That's just x, and then this is x minus 30. Take a moment to do that. All right, so I would like to attack this like a riddle or a puzzle. I would like to get as much out of it as possible. So I would like you to stop writing again, and I would like you to think. And Stephen started us off by saying, yeah, we can write an equation based on the different theorems and postulates we've learned. So, someone fire the first shot. Set up an equation for us and give me the reason that supports it. Go ahead, Sebastian.
2x minus 135 equals x minus 30.
Okay, 2x minus 135 is equal to x minus 30, and what is your reason?
Corresponding angles possible.
Yeah, nicely done. Eric.
X minus 30 equals 75 because of the alternate exterior angles theorem.
X minus 30 equals 75 because of the alternate exterior angles theorem. Look at that. Right there, alternate exterior angles. They're going to be congruent. Beautifully done. Kadir. 2x minus 135 equals 75 because of the vertical angles congruence theorem. Vertical angles. This angle is congruent to that angle. Very nicely done. Give me another one. Should be thinking about what Alexandra said for the checkpoint. Go ahead, Nathaniel.
I'm just gonna say something that's mistaken in my mind. Angle ABF is plus 75 degrees equal 180 degrees.
Okay.
Segment addition postulate. Angle addition.
Well, it's the angle addition postulate, but they're also a linear pair, which makes them supplementary, and that's why it equals 180. But we don't know what this is, so you could figure it out by subtracting it from 180. Very good. That can lead to a bunch of things. Good. Nicely done.
Find X Y.
Kenny?
Yeah.
How come?
They are corresponding. They're the corresponding angles postulate.
What is corresponding to this?
Angle ABF.
Yeah, that was beautiful. This is also going to be x because it's corresponding to this, which means you could set up yet another one. X plus 75 is going to equal 180 like he just said. There's more. There's many more. surprised, Alexandra, you didn't do the one you said already.
I kind of see this now.
Okay, well, what was the theorem that you brought up during the checkpoint?
Consecutive
So what are consecutive interior here?
2x
And, yeah, and consecutive interior are? Consecutive interior angles, theorem says that they are what?
Oh, supplementary.
Supplementary. So those two will add up to 180. Kamoy, you saw another one? You were going to say that one? I mean, there's so much in here that you can do. I mean, you could do this plus this. It's going to be 180 because that's a linear pair. You could use Ziamaro's technique of substitution if, no, I'm sorry, we already have it because of the alternate exterior. I mean, there's so many different ways you could go. So we have 5. There's probably a bunch more that we could do. If you proposed one of them, you have to solve your own. Otherwise, pick the one that you think is the hardest. Pick the one that you think is the hardest and solve for x. Don't pick the one that's the easiest. And I mean, you shouldn't even have to do much. What does x come out to? Caleb? Nope. Can't be 45. Sorry, you made a computation error somewhere. Valerie? It's 105. X must be 105. So we solved for x, and now find the measure of EDG and BDG. EDG is right here. What's the measure of that angle? What if I did this? And asked you to tell me the measure of that angle? Kamoy? Yeah, it's 75 because it's alternate exterior with this. And what about BDG? This one right here, that's x. We already know it. X is equal to what? Stephen? 105. So this one's 105, that one's 75. Did anyone discover anything about these pictures? Anyone discover anything about these pictures? How many different angle measurements are there altogether? Kamoy? Yeah, what are they? Yeah, no matter what, the angles are going to either be 75 or 105. If that's 75, then so is that, and so is that, and so is that. If that's 105, then so is that, and so is that, and so is that. It's either 75 or 105. Any questions about that? Well, let's take a look back. Did it happen with this one? That's 70, so that's 70, so that's 70, so that's 70. That's 110, so that's 110, so that's 110, so that's 110. Checkpoint number 2. Find me the measure of ABD, and I want to clarify, because it was a little bit hard to squeeze it in. This is the measurement of that angle, and that is the measurement of that angle. So remember, you don't have to copy anything, you just need to get me the answer, and you've got 1 quick minute. what'd you get? Measure of ABD. So let's go with numbers 1, 3, and 7. Number 1, what'd you get?
60.
Number 3 is not here. Number 7.
60.
So you two think it's 60? Give me a thumbs up if you agree with the proposed answer. A lot of people think it's 60. It's 60. Anyone have any comments or questions? Can someone tell me the theorem or postulate that you used? Theorem or postulate that you used? Stephanie?
Alternate interior
Alternate interior
angles theorem.
angles theorem is the one that jumps out at me too, because right here and right here. Nicely done. Any comments, questions before we go to the ultimately high level? You guys are doing great so far. So now, example 3. We elevate the complexity a little bit. As you get older and you start exploring different career options such as engineering or architecture or something like that, you're rarely going to deal with a simple picture that just has 2 parallel lines and a transversal. Anything that you would deal with would be much more complex. But if you think about, like road construction, architecture, parallel lines are critical. I mean, think about a road. It has to be parallel. I mean, it just has to be. So figuring out how to make that work within a complex road system is a challenge. This picture is actually supposed to be from the world of music. So I left out some of the labeling because it was actually a little confusing to me. But the vertical lines are supposed to be strings from an instrument. And I think these were supposed to be the motion of the fingers going across them or something like that. I got a little confused by it, so I took the picture. That was really the most important part. Using your ruler, you can draw the 3 parallel lines, and we know that they're parallel because it says it right there, there, and there. You can hold the ruler in the middle right here, draw the line on the left, line on the right, and then move the ruler here, and then line it up here, and then draw this line. And then you can estimate the other 2 lines. Give you a moment to do that, and then we're going to dive into this one. So, before we attack this, we have to have a basic understanding of what is needed. And you should honestly already know what we need. But I want to frame it a little bit. So let me go backwards, and then this will come back in a second. To find one variable, to find one missing variable, how many equations do we have to find one variable? I know we wrote 5 of them, but how many did we actually need? Nathaniel?
1.
You only need 1. If there's 1 variable, you need 1 equation. But if there are 2 variables, how many equations do we need to find the 2 variables? Sebastian? We need 2. If we set up 1 equation, it's not enough. We can't find any of the variables. The key is finding the system. So this picture is pretty complex, so I'm going to do what I usually do, and I'm going to get rid of some of it to help myself focus and help you focus. So let's get rid of this for a moment. Something's not right. Let me get rid of this for a moment, and let's focus on the top part. We need to set something up from that. Let's fill in what we know. Now we have a series of parallel lines, not just two parallel lines. But we can apply one set to the next. Watch this. Let me go one step further and get rid of this. What could you tell me about this angle right there? Every single hand should go up. Every single person should know. What's that angle right there? Matthew?
55 degrees.
How come?
The corresponding angles.
The corresponding angles postulate. What's this angle right there? Use your calculator if you have to. Alexander? 125. Is that right? Yeah. 125. How'd you figure that out? It's a linear pair and they're supplementary. So now watch this. Now we have this expression for this angle. So what equation could we set up with what we have in the picture? Just got one idea. You don't see it yet? Look at the theorems that you have. Look at your cheat sheet. Go ahead, Kamoy. Exactly. 5x plus 4y is equal to 55 because of what? Beautifully done, Kamoy. These two angles are alternate interior. They are congruent to each other, so you can set up an equation. But as I already indicated, we can't solve that because we have an x and a y we can't solve. We could isolate a variable, but we still wouldn't be able to solve it. So now the other half of the picture comes into play. And what did I do? Messed up that. So now we have this angle here, and we have 60, that's for this angle right here. So what equation could we set up using the new information that I've revealed? Would it help if I block this out now?
Good afternoon, teachers and students. It is now time for the afternoon announcement.
Let me get to
The
the
following
homework
students
and
please
we'll come
report to
back
my
to it.
office.
So you can go ahead and copy
Owen.
down your homework.
Rebecca Rodriguez, Philip Hudson, Wasim Khalil, Fabian Rivera, Mizell Mueller, and Valentina Di Paolo. Please report to the front office. The future educators of America are collecting school supplies for people in need. Please bring any school supplies to room 224 before